phases of matter unit project, I did a candle demo. So starting off with objective 4, it asks to define and contrast between evaporation and boiling. So starting off, evaporation is the process of a substance in a liquid state to change to a gas due to an increase in temperature and or pressure. Boiling is very similar, but it occurs through a liquid creating bubbles. Both evaporation and boiling is happening in this demo. As the heat on the stove increases, the water will begin to boil. As the water boils, the amount of heat continues to increase. As the water boils and the amount of heat continues to increase, some of the water will become a gas and evaporate. Objective 7 talks about the effects changing external pressure has on the boiling point. So in order to reach the boiling point, the atmospheric pressure needs to equal the vapor pressure. If the atmospheric pressure is greater than the vapor pressure, the pressure pushes down on the nascent bubbles, making them pop. So boiling cannot occur. Time and temperature also play a role. The more external pressure you put on a liquid, the less time or temperature, also heat, is needed to reach the boiling point. Objective 6 asks to describe the change in vapor pressure with changes in kinetic energy and changes in atmospheric pressure. So basically, as the kinetic energy increases, so does the vapor pressure. Once the vapor pressure equals the atmospheric pressure, boiling will occur. So the water in this demo's vapor pressure equals the atmospheric pressure, and that is how it is at the boiling point. Objective 2 asks to explain how the kinetic molecular theory explains the physical properties of gases. The kinetic molecular theory states that the average kinetic energy of a gas particle depends on the temperature of the gas, and as the temperature increases, the evaporation rate also increases. This is happening with the boiling water and the melting wax. So as the temperature of the stove continues to increase, the more water will evaporate and the more wax will also evaporate. So objective 12 deals with the heating curve. So here you can see the heating curve for water. As you see, there are large amounts of time before the water changes phases. For example, changing from a solid to a liquid. This makes water a lot easier to control. Wax, on the other hand, has relatively short transition times. That is why in this demo I have to use a water bath. If I didn't, the wax would melt too rapidly. Objective 9 asks to define and contrast between crystals and amorphous solids. So crystalline structures have no repeating pattern of molecules or ions, but the spacing between particles is repeated. Crystalline structures tend to be more opaque, strong, or in other words, breaking along set lines. The finished candle is more of a crystalline structure because it is very strong and you cannot see through it. Also, if I were to break it, it would break along set lines. Amorphous solids do not have a set spacing pattern, but the particles are still locked into place for the most part. Amorphous solids tend to be more transparent, weak, and flexible. Or in other words, it breaks in a random fashion. For example, glass, you can see right through it, and if you were to break a piece of glass, it would break in a random fashion. Objective 13 asks to describe how the strength of the intermolecular forces, external pressure, and available energy affects the state of matter of various materials. Intermolecular attraction is very strong as a solid but weak as a gas because the bonds between the molecules in a solid are strong to keep the shape of a solid, while a gas does not have a shape and doesn't need strong forces to keep the shape. Available energy or temperature is low as a solid because a solid does not have a high kinetic energy. Because the atoms in the solid do not move as much as a gas, which has a high temperature and more available energy. Lastly, pressure is higher as a solid than a gas because the molecules in a gas are so spread out, while in the solid, pressure is pushing the molecules together. Objective 8 asks to describe the motion of particles in a solid state. So, within the solid candle, the particles are very close together, and they stay mostly in one space. That's why it holds its shape. Objective 5 asks to describe the effects of evaporation on the average kinetic energy of the remaining liquid. Higher energy particles leave during evaporation or boiling, and then the remaining liquid has a lower kinetic energy than the particles that left during evaporation or boiling. For example, when I light the candle, the wax evaporates the higher energy particles, leaving the remaining wax at a lower kinetic energy. Objective 3 asks to describe the motion of particles in a liquid state. So, liquids do not have a definite shape because the particles are farther away from each other as a liquid. However, particles stay near each other because of attractive forces. So, since this candle has been lit for a while, you can see the liquid wax sits on top of the solid and keeps the shape of the solid. You can also see that in the picture to the right. Objective 11 is just about the phase diagram. So to start off this demo, I brought water to a boil. Water is a liquid, and when brought to a boil, which is also called vaporization, some water will evaporate or become a gas. Then I made the solid wax a liquid by melting it down. Then the melted liquid over time became a solid, which is called freezing. The rest I did not do in this demo, but going from a solid to a gas is called sublimation. Going from a gas to a solid is called solidification, and a gas becoming a liquid is called condensing. So Bose-Einstein condensate and plasma state is not about my demo, so I'm just going to go over it quick. Objective 15 asks to describe Bose-Einstein condensate. To start off, a normal boundary between atoms is caused by electrons repelling against each other. So at a very low temperature, just above 0 degrees Kelvin, there is less repulsion as the electrons slow down, allowing the electron fields to overlap. And this overlapping of atoms is called superatoms. Objective 14 is about the plasma state. So in the plasma state, there is enough energy to break electrons away from individual atoms or molecules. This creates a sea of free electrons and cations. It flows like a liquid because there is little intermolecular attraction as the electrons are pulled away from each other. So to go into my questions, why do nascent bubbles pop? Is it when there's too much pressure or too much heat? The answer is too much pressure. Does wax have a shorter or longer transition time than water? Wax has a shorter transition time. That is why I had to use the water bath. Was the finished candle a crystalline solid or an amorphous solid? The finished candle was a crystalline solid. True or false? Vapor pressure needs to be higher than the atmospheric pressure in order for water to boil. This is false. The vapor pressure and atmospheric pressure need to be kept the same. True or false? Liquids do not have a definite shape. True. And then here is just my works cited page, which just has the video on how to make a candle. So thank you guys for watching my video, and see you in class.